In the immensity of the cosmos, humanity has merely begun to explore. Despite our constrained comprehension, we've often speculated on the existence of life beyond Earth, sometimes wondering if we're solitary in the universe. Yet, a groundbreaking event unfolded with the arrival of our first interstellar visitor, Oumuamua, an entity unlike any we've encountered, sparking wonder about the unknown realms beyond our planet. Notably, the esteemed astrophysicist Neil deGrasse Tyson recently unveiled never-before-seen declassified images of Oumuamua, stirring curiosity about who sent this extraterrestrial envoy, the significance of the Earth effect, and its connection to Oumuamua. Embarking on a journey into space's depths, guided by astrophysicist Neil deGrasse Tyson, we uncover the enigma surrounding this peculiar interstellar wanderer. In 2017, an extraordinary find using the Pan-STARRS 1 telescope by Rob Warwick introduced us to an object hurtling towards Earth. The appearance of Oumuamua ignited a radical shift in our understanding of space and its endless possibilities. Despite its fame, our knowledge of Oumuamua has remained scant. In light of public intrigue, Neil deGrasse Tyson disclosed previously secret, highly classified images of Oumuamua through his expertise, unveiling its significant impact on our solar system. Before delving into the mysteries enshrouded in these long-concealed images, it's crucial to appreciate the captivating essence of Oumuamua. On October 19, 2017, the Hawaii-based Haleakala Observatory made a seminal observation of what appeared to be a comet or asteroid. However, it was later recognized as the first interstellar object detected within our solar system. Besides dust grains, its peculiar orbit and swift velocity suggested its extraterrestrial origin, earning it the name Oumuamua. To understand its form better, astronomers have compared it to similar solar system objects like the asteroid 25M143 Awa, which the Hayabusa spacecraft visited in 2005. While Awa shared some features with Oumuamua, the interstellar visitor's unique elongated proportions and absence of a tail set it apart. Adding to the mystery is Oumuamua's remarkable acceleration, akin to a bicycle suddenly speeding up without pedaling. Entering our solar system from above, it came remarkably close to the Sun before continuing below the planetary plane, maintaining an extraordinary speed of about 196,000 miles per hour, indicative of significant kinetic energy. This speed is unparalleled by any human-made object, underscoring Oumuamua's unique journey through our solar system. The high velocity of Oumuamua has prompted a hypothesis suggesting that it might have originated from a binary star system. This theory proposes that gravitational interactions within such systems can impart high velocities to objects. If Oumuamua did indeed come from a binary system, the gravitational forces from the stars could have propelled it on its interstellar journey, explaining its remarkable speed. Beyond its speed, studies have unveiled intriguing details about Oumuamua's composition. It features a thick outer layer akin to a cosmic shell made of carbon-rich materials solidified by cosmic radiation during its extensive journey through interstellar space. Beneath this protective exterior, Oumuamua reveals its remarkably dense inner nature, primarily composed of rock, possibly containing metallic elements. What sets it apart is the absence of water or ice, distinguishing it from typical comets or icy celestial bodies. Additionally, Oumuamua's surface has a reddish tint, a result of prolonged exposure to cosmic rays over hundreds of millions of years. Several individuals have called for contributions from renowned experts like Neil deGrasse Tyson and Michio Kaku regarding Oumuamua. Interestingly, Neil deGrasse Tyson refrained from commenting on the matter until substantial evidence and the recent declassified photos became available, leaving everyone eagerly anticipating his perspective. Some researchers suggest that Oumuamua's elongated form, inferred from its light curve, indicates that it could be a fragment of a larger body. If Oumuamua broke off from a larger object due to a collision or other violent events, it might have acquired substantial velocity during the separation process. This would imply that Oumuamua's speed is not intrinsic to its nature but rather a result of past events. Comparisons can be drawn with comets and asteroids in our solar system, which traverse at varying velocities. While some comets can achieve speeds comparable to Oumuamua, they typically exhibit residual gas and dust due to their volatile composition. In contrast, Oumuamua displayed no such characteristics, distinguishing it from known cometary objects. Similarly, most asteroids in our solar system move at significantly slower speeds than Oumuamua. The average orbital velocity of the well-known asteroid series, for instance, is approximately 17,800 kilometers per hour, less than a fifth of Oumuamua's estimated speed. This disparity underscores the exceptional nature of Oumuamua's velocity and its distinction from familiar solar system objects. Some experts speculate that Oumuamua could be more than a naturally occurring object. They suggest that it might be an artificially crafted creation meticulously made by an advanced extraterrestrial civilization. According to this theory, Oumuamua's unique features could serve multiple functions. Its elongated structure could enhance its resilience during interstellar travel, while its propulsion system could enable precise maneuvering through the cosmos. Figures like Avi Loeb, an Israeli-American theoretical physicist and astronomer, strongly support this theory. Loeb even proposed a controversial hypothesis that Oumuamua could be of extraterrestrial origin, suggesting that it could be an artificial object or even a piece of alien technology. He argued that its peculiar properties, such as its elongated shape and unusual acceleration, could indicate an artificial origin. Loeb's hypothesis sparked widespread discussion and debate within the scientific community. However, it's essential to note that many scientists and astronomers have expressed skepticism about these claims. The prevailing view among most scientists is that Oumuamua is likely a natural object, such as a comet or an asteroid, with its unusual properties being the result of natural processes. Wesley C. Fraser and other researchers used combined brightness measurements from multiple telescopes to investigate its rotation period. They concluded that no rotation period can account for the observed brightness variations. Instead, the object appears to be tumbling in an excited rotational state, a motion unlike anything seen before. This irregular rotation has puzzled scientists since its discovery. Observations by astronomers have provided valuable insights into Oumuamua's spin. It completes a full rotation every 7.3 hours, which is relatively fast compared to the rotational periods of other objects in our solar system. Additionally, its brightness varies significantly as it spins, indicating that different parts of the object reflect sunlight to varying degrees. This irregular rotation has perplexed scientists and led to various intriguing theories. One hypothesis proposed to explain Oumuamua's spin is the spin-induced outgassing theory. According to this idea, volatile substances beneath its surface are exposed to solar radiation as the object tumbles through space, causing it to vaporize and create tiny gas jets. These jets act as thrusters, imparting a torque on Oumuamua and causing it to spin irregularly. Another theory suggests that Oumuamua's tumbling motion could result from a prior collision with another object. It is conceivable that a high-speed impact distorted its shape and set it into an irregular spin. However, the exact nature of such a collision and the object involved remain speculative due to limited observational data. Detailed analysis of Oumuamua's shape, composition, and surface features could provide clues supporting these theories. To better understand Oumuamua's peculiar movement, let's examine other celestial objects with similar behavior. One such object is the asteroid 4179 Totatis, discovered in 1989, which displays a tumbling motion akin to Oumuamua. Scientists have proposed several theories to explain Totatis' erratic rotation, including the YORP effect. According to this effect, sunlight exerts a torque on the object due to uneven thermal radiation, gradually altering its rotation and leading to its irregular tumbling motion. Another example is Comet 67P/Churyumov-Gerasimenko, often called 67P, which also showcases irregular rotation. Researchers discovered 67P on September 11, 1969. This comet orbits the Sun and exhibits a striking shape and distinct movement, featuring two distinct lobes connected by a narrow neck. It belongs to the Jupiter family of comets, indicating that its origin can be traced back to the Kuiper Belt, a region beyond Neptune populated by icy bodies. However, researchers believe that gravitational perturbations caused by Jupiter's immense gravity captured 67P into its current orbit. In the case of Oumuamua, Scientists believe that the outgassing of volatile substances from its surface plays a significant role in its tumbling motion. As the ice on the comet's surface vaporizes under the influence of solar radiation, it creates localized jets that act like thrusters, altering the comet's rotation. The similarities between Oumuamua and these objects hint at potential underlying mechanisms responsible for their unusual spins. Further exploration and detailed analysis of these objects can provide valuable insights into the nature of Oumuamua. The origin of Oumuamua has also been a subject of great speculation. Some scientists proposed that it could be a fragment of a larger body ejected from its home star system due to gravitational interactions or a catastrophic event. This ejection might have imparted an initial spin on Oumuamua, which has persisted throughout its interstellar journey. The exact process by which Oumuamua was ejected and its subsequent trajectory remains uncertain, highlighting the need for more data and further research. However, there is a possibility that Oumuamua is a byproduct of a collision between two objects in a distant star system. The resulting debris could have been flung into interstellar space, with Oumuamua being one of the fragments caught in our solar system's gravitational pull. Without further evidence, these theories remain speculative. Detailed analysis of Oumuamua's composition, isotopic ratios, and surface features could provide clues about its origin and shed light on the mechanisms involved in its peculiar spin and movement. As shown in these images, the absence of visible emissions baffled scientists even more. This exclusion of visible emission eliminated the possibility of Oumuamua being a typical comet or asteroid and presented an intriguing puzzle that required further investigation. There is a possibility that Oumuamua's lack of emission could be explained by it being a dead comet. A typical comet's icy composition vaporizes as it approaches the Sun, resulting in an emission trail. However, if Oumuamua had lost most of its volatile materials due to repeated close encounters with stars in its long interstellar journey, the absence of visible emission could be accounted for. Intense heat and radiation from these encounters may have stripped away Oumuamua's volatile components, leaving behind a rocky or metallic body without the usual coma features. This gave room for the possibility that Oumuamua is an interstellar asteroid. If Oumuamua were an asteroid, the lack of visible emission could be explained as asteroids generally do not exhibit the same outgassing behavior as comets. However, the elongated shape of Oumuamua remains a mystery, as asteroids in our solar system tend to have more irregular shapes. Some scientists propose that the elongated shape could result from gravitational distortions experienced during close encounters with a star or a planet in its parent star system. Similarly, asteroid Bennu, the target of NASA's OSIRIS-Rx mission, provides an interesting comparison. Bennu, classified as a primitive carbonaceous asteroid, did not display any visible emission during its close encounters with Earth. However, this lack of visible emission was expected, as Bennu's composition was predominantly rocky with minimal volatile content. This demonstrates that asteroids, unlike comets, generally do not exhibit visible emission, aligning with the notion that Oumuamua could be an interstellar asteroid. What were Neil deGrasse Tyson's views on the declassified images? Upon releasing the declassified images, Neil deGrasse Tyson assumed the responsibility of actively exploring and explaining the nuances and potential implications of Oumuamua. Neil deGrasse Tyson consistently emphasizes the importance of evidence-based inquiry in his discussions on Oumuamua. He highlights the need to approach the topic with skepticism while exploring the fascinating idea of Oumuamua as a message. This approach reflects the beauty of scientific exploration, where extraordinary hypotheses are considered, tested, and either validated or refuted. Tyson suggests that the universe might be far more mysterious and intricate than our current comprehension. He also contemplates Oumuamua as a test that gauges our technological and scientific advancement. How we perceive, study, and react to Oumuamua could provide valuable data to its creators about our civilization's maturity and readiness for potential contact. This perspective extends beyond the object itself and raises broader questions about our technological and philosophical readiness to understand and interpret such phenomena. Tyson postulates that Oumuamua's sudden appearance and the subsequent scientific activity it triggered could be seen as a test about technological capabilities. The fact that we could detect, track, and analyze it indicates our growing capabilities in space observation and research. Moreover, Oumuamua challenges our scientific paradigms with its unusual acceleration, unique shape, and trajectory that defy easy explanation. Tyson sees this as a test of our scientific flexibility. Can we adapt our theory and models to accommodate this new data, or will we try to force it into pre-existing frameworks? Oumuamua's brief passage through our solar system required rapid, coordinated efforts from the global scientific community. Tyson sees this as a test of our ability to collaborate, share data, and pull resources in the face of a sudden and unexpected cosmic event. It raises the question of how we performed in this test and what lessons we have learned to prepare for future stellar visitors. Delving deeper into the test hypothesis, Tyson speculates on the broader message behind Oumuamua. If it was deliberately sent our way, perhaps the test is not just about detection but interpretation. Can we understand a message or signal embedded in its structure or behavior, and if so, how do we respond? These questions remain unanswered, and the search for answers continues. Another perspective Tyson explores is the idea of Oumuamua as an interstellar emissary. Instead of being a mere probe or artifact, could it be a vessel carrying representatives from a distant star system? While this theory may seem like science fiction, Tyson argues that we must consider all possibilities, no matter how outlandish they might seem. After all, the universe is vast, ancient, and full of wonders yet to be discovered. Tyson's contemplation of Oumuamua as either an interstellar artifact or a mere cosmic coincidence demonstrates the depth of his scientific inquiry. His approach blends wonder, skepticism, and rigorous scientific analysis. It challenges our understanding of life in the universe, the nature of celestial objects, and our place in the cosmic tapestry. The implications of Tyson's theories are vast, ranging from technological advancements to philosophical introspections. They disrupt conventional astrophysical theories and potentially reshape our understanding of the cosmos. If any of his theories hold, it would mark a significant paradigm shift and propel us into a new era of space exploration.